So here's the greeting from Austin, Texas. Anybody have been in Austin before? Here we go. We've got a couple of people, 3. So these are some of the things that actually give you attraction to make a visit. The South by Southwest, which is what you see here. That's a huge 9 days multimedia conference, technology and cinema and all types of educational things that is quite famous. Over 300,000 people come to Austin every year, and a number of other attractions, including the state capitol. I'm also proud to say that we have quite active also IEEE chapters, and we're part of Central Texas section, and one of the key chapters is the same as you have here, the Communications Society chapter. And I'm glad to say also that we have worked hard over the last 10 years or so, and we're able to secure and win a couple of awards or prizes from the Communication Society. One was actually in 2015 across North America. As you can see here, that's all. And the second one, it's called Chapter of the Year Award, which going across all the chapters worldwide. There are about 212 chapters. And so we're really able to get both, secure the regional award as well as the global award for 2 years, 2015 and 2017. Just this is the last slide, just to get you acquainted with where I'm coming from. So I'm a part of the Central Texas section. I'm actually also the chair of the Central Texas section. You see the officers on the right-hand side, as well as also we have student chapters and student branch, and then a number of committees, and we have about 25 chapters spanning different counties, as you can see here, from Austin, San Marcos, San Antonio, which is getting closer. So we have a lot of opportunity for growth. So anyhow, getting back to the subject, and just want to change a bit. So I'd like to first of all maybe ask a couple of questions. A lot of you are involved in different areas. Some involved in research, right? Okay, and some in development, great, and some in engineering. All right, we got sample cross section, and also regarding the subject itself. How are you familiar with the whole concept of IoT? Okay. And so the rest is really interesting to know more about it. And those who know a bit about IoT, are you involved in any way in applications related to IoT? Okay, very good. At least that gives me a good idea. I wanted to make sure that what we have as a takeaway is that all of us have a clear understanding of IoT. So whether you read about it, whether you get involved in it, you have a good visual concept, as well as a feel of different application that IoT is involved in. And also be aware of the emerging technology and the roadmap and the use cases. And many of us hear a lot about 2020 and where there could be a lot of intersection of technologies such as IoT in a big way and 5G in another way, and virtualizations and things like network slicing and so on. So all of these things probably will have a major impact in terms of rolling out services, not just the technology impact, but actually the application itself and the use cases. So I organized the flow of the presentation in a simple way. First, for us all to understand a little bit more about IoT. Is it something new or is it something old, and we're just respinning or rebranding it. So that's really the first section of it, and then understand the technology around it and the standards activities before we indulge into more specifications. And I picked up 3 areas to talk about: smart connected home, smart building, and also smart energy. I think that's more targeted to your needs. And then once we finish having a sample of these areas where this technology can take us in the next few years, then we need to look ahead in the next 5 years or more as to see now the emerging technologies, how it's going to impact in terms of scaling solutions and having it more secure and expandable. So that's essentially the area. Feel free, as Jesus mentioned, interrupt me at any time. The things are not clear or running fast, and I'll be happy to respond to. So I start always with a simple picture, more or less to say why do we need IoT in the first place, especially those who have no idea. As you can see, there are all types of, I call it objects in the pictures. Of course, we know about the computers, we know about people, but you can see certain things like thermostat that is sitting here, metering, which we're acquainted with, camera, light bulb, maybe things like sprinkler system, and also maybe health watch, like me, for example, iWatch and things like that. And maybe some things like hearing aids, things to monitor. Maybe if they're in a different room and wanted to ensure certain motion or so to be detected. So these are all objects that we take it for granted. If there is a thermostat somewhere, you just go there and adjust the temperature. Some sophisticated thermostat have programmable capabilities. Some, the fancy ones that start emerging, that you can program it from your mobile device. So that's really what this area symbolized. Can I extend the capability to manage the thermostat remotely and program it to function in a certain time, so that, let's say if I'm away, I can lower the temperature. Before I return, I can start increasing the temperature to make it more comfortable. If I'm on vacation, can I do something different? Can I schedule for a whole week, certain style of temperature management at night versus during the day and so on. So that now gives you vast opportunities that were not available to us before. You can connect to an object that's in a fixed place, and you can be anywhere. You can be even overseas. You said I forgot actually to make the adjustment to the thermostat before I left. You can still operate that through the internet. So that gives you a vast amount for just one object. Imagine if we start looking at all these other objects. Metering, we take it for granted. The meter is running, and the people in the past could pass by and take the reading. As we move advance, people stop by, and maybe from the car we have connectivities now that they can read through Wi-Fi the reading of the meter itself and leave. These are all so that they can send you a bill at the end of the month, whether that's for electricity or gas or other means. So that meter itself is taking a revolution, and both in the interest of the utility company as well as the interest of the consumer. And the utility companies, as I introduced a couple of examples, by the fact that they can now do reading remotely, how much saving that they have in terms of operational costs, in terms of people traveling to do the reading and return back and so on, how accurate the information they are getting now, reading it directly or remotely. And that doesn't stop there. This is just simply connectivity's aspect of it. But what you do with the reading is a totally different things. So initially, yes, you send it out as a bill at the end of the month. But hey, well, the consumer has not benefited anything from the saving that the utility company is doing. So what's happening in different countries is that they are paying back some credit to, or extending saving to consumer by certain means. So you say, if you use electricity between such hour and hour 8, from, let's say from 8 o'clock at night to 2 o'clock in the morning, for example, we're going to cut the rate by half. That's interesting, that's an interesting option. So many people could run their machines, their washer, their dryer, and so on around that time of the night. And that represents a saving on the part of the consumer, give them flexibility to choose. And it is a win-win situation. It also rotates and helps actually the utility company by managing by having conscious consumers. You will be able also to manage the distribution of energy and load balancing. So as we go forward, then you can also rebate saying that I'm a good consumer, I'm conscious of the energy consumptions, I'd like to have a rebate with the utility company over time so that I can return back. I'm supposed to use, let's say, I don't know, for 4 kilowatt or so, I end up using, let's say, 2.5 kilowatt. So that saving, I can return it back to utility, to the grid, and I can get saving for it in terms of credit or things like that. So now we're starting establishing an interactive smart dialogue. So this whole notion of IoT is supposed not only to mechanize things or automate things or connect things or having remote management, but really eventually should be able to have intelligent communications between the consumer and the provider in a way that all becomes a win-win type of situation. And so I can just give you a couple of examples. You can easily do with the video surveillance, you can do with the sprinkler system, which apply also for fire distinguisher that could be on let's say, the roof or manual units. Of course, the lighting and many other things. So what I have shown in this particular example, since IoT is in the business of connectivities and in the business of extracting information, it would be nice to collect that information in a central point. In this case, it's called data storage, or it could be the cloud, as you may have heard in different technical applications. And as you collect information from different sources, these essentially can become different point solutions. So if I have my mobile device now, I can operate each one individually. I can click on the thermostat, I got the menu of thermostat in my iPhone, for example, and I can really manage that. Same thing if I have something about utility or appliances that I'm managing, that be able also to operate it from the iPhone. But that represents so many applications sitting on my iPhone. Each becomes a single point of solutions. And that's really what the next step is. If we are connecting these things to be a single point solution, there must be time to come and say, yeah, but there are many things that are related to each other. Lighting, for example, could be relating to, if we turn the light on, maybe turn the curtain down, or you watch also the door for access door for the house or the before sleeping or things like that. So many things could be, the information you are collecting from different sources could be related to each other. So that, if you have information here at the central point, give you an opportunity to be able to analyze that. That's really the basis. I'm trying to simplify that, give a little bit a base of what IoT can do. We call all of these things objects, and these objects have a certain characterizations, as you can see, pertaining to a certain function. So I picked up the functions that related, maybe here in this case, in a home environment and related to safety of the environment. All those in the black lines really represent some level of environmental safety. If I go to the next one, which has the red dots and red lines, as you can see, they are pertaining to things dealing with hearing aid that you can adjust for an elderly person to tune it in such a way that it becomes optimal. You can adjust it to the vital signs for an individual that could be monitored nowadays, merging with the smartwatch, or it could be monitoring certain condition of individuals, either a person that's sick or patient, or a baby somewhere else that you're looking at their safety. So in that sense, you are looking for also objects that could be related to health and fitness. So in that sense, you have two scenarios, one really covering the environment, and the other one is covering health and safety. And you could merge these two examples and build up other scenarios. And this is only for tiny set of examples. So the notion and the concept of IoT is such huge that if you understand it from that simple way, I think you'll be able to see it in a much complex type of environment, as we'll see in a few examples later on. So again, so here I combine the two examples and say, hey, I'm managing now multiple scenarios, things related to safety and things could be related to health and wellness. So if I summarize what we have seen so far from those little couple of pictures, we could see that what we have done is nothing more than providing connectivity to objects that were not possible. I could connect to the projector here, and I can manage it from anywhere. If there's a failure, if the bulb fails, for example, it should be able to tell me an alert from one of the LED, and people will be notified not only through their control center, for example, but also coming down to their iPhone. If it is, you are extending your functionality to receive such alert on your iPhone. So nothing can be ignored. Whatever is important to you, or whatever is important to the company, whatever is important to an institute, these are what you really build an IoT solution for, so that you can get maximum value out of it. So that's more of a definitions in terms of providing connectivities, extracting the data information, and take a decision on it. So the concept, as you can see, it is natural. It's intuitive. And we have witnessed it for years, decades. But maybe it did not come under the term IoT, but it came under different terms. It came under industrial IoT, or maybe it was not industrial IoT, it was called data acquisition. There's nothing more different from data acquisition from what we see here, except the technology and the mechanism and so on. So this is my first actual job experience dealing with pulp and paper industry. Is really working all the way of the stages from producing the finished product, which could be tissues, it could be paper, it could be many things from the pulp itself, where there are different sensors at different stages, as you can see here. It's going all the way from the pulp to the finished product. And you have various sensors to look at different aspects, moisture content, the thickness, formation, capacity, brightness, color, and so on. This exists in every environment, have a different types of sensor for different purposes. But that exists, that was back in the 70s that these types of machines still running, pulp and paper machine. And you can, I was actually, the assignments I have is the what's called polysensor, which is a sensor. It's really checking the type of, the color and opacity of the paper and brightness of the paper itself, and compare it to the actual calibrations information that we receive about the color spectrum. And these were all done in real time, and therefore, if there's any deviation from the actual set or reference value, you could adjust by adding a certain amount of dye or a certain color to be able to achieve the desired results. And so that was back, I programmed that myself in a similar language back in the late 70s. The other thing that these are also personal experience. I think, as was mentioned, I work with the international carrier called Teleglobe Canada, and as you can see here, north of US, we have a whole communications telecommunication from east to west internally, but connected to about 250 administration worldwide, connecting to Mexico, connected to France, connected to China, you name it. And we have at the edge of near the ocean, I guess, Pacific Ocean or Atlantic Ocean, we have different means. We have under the seas, under ocean cables. At that time it was called Contact 3, or you can go through satellite, international satellite at the Atlantic as well as at the Pacific. My job at that point was, I was also R&D, and I was given a challenge, part of the corporate task force, to develop a program for network management and R&D activities. And the task was really looking at all these tons of equipment that we have and how can we intercept these equipment to ensure that any failure in any equipment, regardless where they are, will be able to detect it, which is like impossible. A lot of these equipments have their own LED in the rack and things like that need the people, local people, to go and check and do their tour, even taking the temperature for different floors and different environments, and also looking at the wind speed, the environment as well as the actual equipment, transmission as well as receive equipment. So essentially I was given the task to build a whole program. And that program looking at the far end area, and these are called satellite-based stations or cable stations, but also where the traffic is concentrated for switching and transmission, and these are called international gateways. And then also the final results, which every company or every institution have what's called the network operation center or network control center. So that also was part of it. We're supervising all the administration, all the quality of service and so on. If anything wrong between administration or complaining, it comes through here, and then they start investigating. So we need to be prepared. If we monitor all this equipment in real time and have an understanding, if there is a failure of facilities, we should be able to determine how much circuits it's affecting, how much traffic it's affecting, how we can isolate that traffic, how we can recover. And that itself was there was actually 20 programs developed as a result of the network management and some study project like artificial intelligence and so on at that time. But as you can see here at the base stations, you have all types of equipment that we need to interface with. And at the gateway, we have to look at it from traffic perspective, fault isolations, configuration and reprovisioning, and performance measurements, and then mapping that all into graphical displays showing the worldwide type of map and status of alarms that are happening at any place of the network itself, and allowing operators to do acknowledgement and with timestamp all the information. So I just want to share that such a concept existed for many years and under different type of environment. I would zoom specifically to an area of, in the satellite-based station, for example. I had building and automation systems. And the first task is to have these companies to monitor all aspects of the power, the distributions, circuit breakers. In that case, we have to look at the switching time between electricity to turbine in the case of failure, and that switch time has to be within a certain time. So it was much more so complicated, but we had it back then, and we had to intercept and get that information. And because the company is also Crown Corporations, all our facilities are leased lines, so it's secure. And as you can see, we have all our data distributed. There's local processing, regional processing, and so on. So, and also, these are not done out of the blue. They are conforming to certain standards, and the standards at that time from ITU was called TMN telecommunication management network. And as you can see, it is a multi-level, all the way from interfacing to network elements to integrations and processing and supervising side. So what we learned from that exercise is really everything else unfold. All what we're doing is the same concept. The changes that are happening is really looking at processor has changed a lot. So processing speed and processing power is more advanced than before. The architecture, what is called SoC, system on a chip, and the real estate of the processor is much smaller, so you can compact a lot of power, and that helps us to have things like real-time processing at the edge of the network or edge computing. The sensors now are getting more accurate, more advanced, more sensitive, more scalable, so you can have, and it can have a huge quantity of sensors that you can manage with lower latency. And of course, the whole notion, as I showed in the first example, is the concept of connectivities and remote management and integration. That's the key for anything. The degree of how you do it, that varies depending on your environment and how far you want to take it. But also, what was different from what we had at network management, it was all fixed and it's all analog and digital and wired and so on. There was nothing about wireless at the time. So certainly with the whole emerging of a new age of wireless technology from short range to wide range, that's enabling a whole gamut of applications that we are being enabled. And the whole notion of cloud-based is also allowing us to be able to analyze the information at different stages, either at the close to the sensors or the equipment or to the cloud for trend analysis and processing. Certainly our interface, instead of having these bulky machines that you're sitting in front of to managing, let's say the control center, now you can really, you don't have to stick there, you could be anywhere with your mobile app or devices. And now, this is important. Now, we all rely on service provider and carrier to give us these pipelines and equipment and services. But the more we add stress, the more we add bandwidth, the more we add application that's bandwidth intensive, the more that give headaches to companies, the more they have to add routers and switches to enlarge the network, the more complex the configurations and setup time. So the concept of the concept of virtualization help us a lot to scale the network, provide flexibility, performance and security and reliability. And why is that? Because I don't know if you watch, I did watch, because when we were doing this network management, we had a lot of technicians, and these guys have to issue a circuit order and to make changes in the network ahead of time, and it goes down to the port level of any particular rack. And if you are dealing with switches and routers, imagine all the ports and configuration that you need to go through. And if that's just for one area, imagine the service provider trying to support so many other institutions. So the virtualization is really helping to abstract all this equipment so that service provider do not have to worry about the brand of the equipment. So they become more of a no brand and allow them to logically provide the connectivities and having a layer underneath to map the virtual into the physical. That's in a simple word where what virtualization will help. And if you do that, you are scaling. Now we can go to bigger, expand and add more features, add more data, add more applications. So these are the key things that I learned that really, if we apply now at different degrees to any type of applications, and especially in building management and energy management, traffic management, etc., that will really help a lot that every vertical market will be able to benefit tremendously. So if I compare what we have done in network management to what would IoT model would look like, which you see in the right-hand side. Now we see a lot more complexity, because now we have, so that's what is emerging in the 2010, in terms of now we are managing all types of sensors for all types of purposes. You have various types of protocols for short range, and you have ways of communicating to your next level. It could be a microcontroller, it could be embedded system. You can do data acquisitions at that level. You can control back, make changes here after certain analysis. Some analysis may have to go up to the higher level because you are integrating more data coming from other sensors, from other systems. So you need to make sure that you have what is called the big data and big data analytics that are running. So that's essentially the simple, I wanted to bring now to some level of formality of IoT, what it will take. But that notion of IoT really started coming into the scene. I don't know, actually I give the clue already in the first sentence. The first notion of IoT becoming a hype in the industry is around 2014. And that's where I was doing a lot of surveys of various companies as to what's going on and why all of a sudden every company started talking about something called IoT. And when you talk to the many reporters talking to the president saying, why do you need IoT for your company? And said, there must be something useful for us to be there. And over time, as you can see, there's a huge investments and collaboration between giant companies, between IBM and Apple, because Apple was so strong in mobile devices, and IBM was more mainframe and professional service, between IBM and AT&T because of the distribution and management, and between IBM and ARM, for example, because of the low power equipment that's being, processor that's being produced, between Apple and Cisco because of the networking capabilities, and on it goes. And I was able to do a lot of research around 2014 and able to develop, co-author a book about the future of IoT back in June in Wiley. That's really summarizing what are the possibilities for IoT, not really for 2020, but the task that was given to us was to do projection and roadmap for 2030 and 2040. Some in the mid-range and some at the far end. And so that's essentially, we did mapping to that area as far as how we can go about following that type of model. Now, to do anything related to energy management or smart connected home and so on, at least we need to understand a little bit on the capabilities and standards. So I'll walk quickly through that. This is more of a, same thing I indicated before, but added a little bit of formality. Any IoT, essentially, if you hear people talking about 5 layers, 6 layers, or 2 layers, and so on, essentially have 3 major areas. One is the sensing side, which you go to the network elements and get the information out, as we saw in the first couple of pictures with the circles. The second one is to get the information communicated to the nearest point for processing. And the third one is really more of analyzing and making a longer-term type of decision. That's in a simple form, and these are the words really associated with it. But in each area also we have a set of protocol that we need to follow, whether it is at the sensing level, and you have a lot of wireless sensors network, ZigBee, near-field communications, Wi-Fi, low-power personal area network, etc., etc. In the mid-range where you have the communications and switches and routers, this is really where you can add virtualization to it, to virtualize your switches and routers, moving from IPv4 to IPv6 so that you have unlimited type of addressability, so that your points that you're trying to address becomes available. We are not restricted or limited by that. And then and this is called virtual layer, and then the cyber layer is more dealing with the cloud and dealing with processing and big data and analytics. So, moving one step closer, Now if we look at the distance in the home, 10 meter, 100 meter, 1 kilometer, etc., and the baud rate on the vertical side, we see different corners for standards. For the low end, short range, we're dealing with things like Bluetooth, and we have a number of associations that are really driving the standards for that. If you go upper in terms of still short distance, 100 meter, which is 300 feet, you can go with Wi-Fi. Of course, they have Zigbee and Bluetooth. And as you move in terms of higher range, you move with different types of standards, sub-gigahertz. So for example, all the power lines where you have transformers, these will be ideal for, it's a low burst, as you can see here, but a longer distance, and we have a different actually standards that can manage that to be able to read the status on the pole remotely. And the same bigger one dealing more on the communication side. And you've seen more on the bottom side is more on the local area, low power, which is what we just talked about, and then cellular network for machine to machine. Any questions or thoughts? Is it flowing okay? So I need to run through this quickly. So this is the same thing as I specified before. This is a grid that you could use when applying your research and development. And this is a whole spectrum in terms of wireless technology all the way from low end to high end. Yes.
Thank you. I have a question in my mind, just to clarify.
Yes.
For example, if you have a SCADA, but before was, if you have a SCADA system and you have all of these things, satellites,
Yes.
fiber optics communication, going all the signals from each station to
Yes.
central control. And I mean, many terms that you mentioned, that you can say is similar, no? The concepts
Yes.
are very similar. So my question is, how I can, if I even in my mind, the border or the limit or what is this kind of system and what is Internet of Things?
Thank you. Very good question. Which is really trying, how can we remove all that confusion that we mixed, that we could see SCADA existed decades ago. What's the difference? And I think what the difference is really what I try to highlight in one slide. This is really the basis. I mean, I try to ask myself these questions. This is really what the changes are. It's the same thing. I had a whole talk in the past called rebranding. IoT is just simply a rebrand of what existed before. Existed before in industry, call it data acquisitions or industry IoT. It started 25 years ago, but nobody's thought of really doing an innovative approach for other types of smart connected home. We do not have that except starting new. So that's really the new terminology for IoT, applying similar concept, is really trying to leverage all those items that we are seeing here. So they are leveraging from each other, and the SCADA is really evolving in terms of technology and leveraging latest technology to give you faster, powerful, scalable, secure type of a solution. That's what we're aiming for. But SCADA is scaled up. And SCADA is part of the notion of IoT, except it's focused on specific area, which is really monitoring the power environments and things of that sort, as you have other systems to, I don't know, you could have something for healthcare, emergency service or telemedicine, telehealth. This is another type of notion. These are all derivatives, new terms and new terminology that will come about leveraging the whole concept of IoT. So IoT is a bigger umbrella. So IoT, as I said in the first few slides, it deals with objects anywhere. What you do with these objects that matter you, you classify the way you want it. Some may come naturally. When I dealt with network management, SCADA exists as a system, and you don't want to change that. Message switching system existed as a system. I cannot change that. Transmission equipment and so on, change in equipment and performance characteristics and so on. So this is evolving. So we're intercepting, leveraging these technology in a similar structure, but it provides the same operations. You're giving better quality of service, lower cost of operations, and better results. So IoT with SCADA today will be more efficient, more impactful than non-IoT SCADA in the past. In one way of interpreting that. Now I can accelerate since we have that strong base. And that strong base is really, I use different terminology from the spectrum that we have here, and saying that anything you look at it, it's either integrated or not integrated. And the left-hand side, what we lived through decades is what I call it segmented solutions. You have solutions, some company only sell things for sensors. Some like Cisco only sells router and switches for networking, which is in the middle layer. And others only selling professional services like IBM. But then everyone is really striving hard to close the gap between one and the other. And that's what you start seeing, collaborations or acquisitions, so that you can close the gap between service and gateway. When I mentioned collaboration between IBM and Cisco, for example, and Cisco and other sensor companies, it's all to close the gap so that they can offer what is called the single point solution. So some people did the single point solution, which is a SCADA in the past. And that single point solution was actually multi-point solutions because they are monitoring multiple things and interpreting many things in a different ways. So that's really the fun way of describing it. It is really, you cannot live with just managing a single point, but really it comes a point that you are collecting and integrating the information at a certain point, as I mentioned, could be at the edge of the network or edge computing, or it could be at the cloud or high cloud network for services and service trends. I also was saying that every market, every vertical market can be also impacting a group of people. It could be impacting the individual network, it could be impacting the industry, it could be impacting the infrastructure. And applying this structure, these things now are not happening. When you have video surveillance, you have video surveillance in the home, you have video surveillance at the front gate here, and you have video surveillance at the infrastructure, at the traffic intersections. So now our applications are really crossing multiple domains. So IoT will change how these things are interconnected, and will change the way we're looking at things. So instead of seeing all these vertical markets, there will come a point of time these will be smartly connected and a flat type of environments that there will be symbolic names for verticals, but they will all functional-wise, they're all smartly connected. So that's the reason behind this. This is more for the future, but there is a healthy sign, as you can see here in IoT, impacting the home, impacting the enterprise, and impacting also the infrastructure. So if we look at the home, quickly we have a lot of things that we can manage, and you already have the basis from the first few slides. So the charter is that we should be able to look at different things. I'm interested more on the things related to heating and energy. So right now, there exists what's called smart plug. That smart plug, you can put it connecting the fridge, the stove, the washer, the dryer, anything you could think of, into the wall, and be able to give you the reading of what your consumption is, and be able to collect the data for you, and be able also to send it to a particular application. Very similar to what I was describing in the first slide. So that gives us now, hey, I can manage to see how can I make, if a certain appliance is costing me a lot, and if I have the information from the utility company of the rate, I could use that appliance in a lower rate and maximizing my efficiency and operational cost reductions than, let's say, just using it without much knowledge. So that's just for one area. The same thing with the lighting, represented coming from heating, for example, and various things dealing with security and heating and ventilation and air conditioning systems. All of these things represent areas that we can manage. Today, I could not have intelligent HVAC at home because the manufacturing company really still dealing with the old system. They do not provide, we still have to go up. They are making it more efficient as a standalone, but in terms of extending capabilities and giving you options to do certain things, we're still distance a few years away. But imagine of all of these things, manufacturers are involved to have energy efficient that is integrated as a part of a smart connected home, then that would be great. That means that the developer has to be notified and as to when customers come in buying a home, they could actually specify, do you need that Model A, which is give you remote access capabilities that you can do it, or you wanted to stay with the traditional one, and here is the cost difference between the two. So that's really what's going to happen. And there are organizations that are working with developers in terms of paving the way to enable the smart connected home to become a reality. So these are all new pieces of information. At the end of the day, I mean, the dream is that saying that, hey, with my iPhone or my mobile app, as you could see on the left-hand side, I can manage anything in the home while I'm sitting on the sofa or visiting my neighbor or at work or traveling and so on. So that's the power, again, of if you have managed to tap into these equipments in a certain manageable way, you'll be able to run the home actually in a more efficient fashion, in a secure fashion. And this will go even deeper into the home itself. You could see, for example, energy constitute the major investments and major growth in terms of market for automation, followed by security, followed by smart appliances. Let's give you a little bit of projection of how things are going. If you want to see a smart home already exists today, I can visit Santa Clara, visit Intel buildings, and outside there is that little tiny house. It's called smart tiny house. It costs the developer about $20,000. They can do anyone for you for that type of price. It really is being monitored and scanned and develop various scenarios. It's even being activated with voice. And you have various scenarios, so you come at a certain time at night, 10 o'clock, you can say, now it's time for bed, so various actions are generated, closing the drapes, closing the TV, turning the light off, closing the shutter, etc., etc. So that's really what fantasy in terms of, if you really want a smart house to enjoy, you can really imagine various things and the technology can help you to achieve it. So the first four items in terms of energy, environment, gas, water, electricity meter, lighting systems, smart plugs, appliances, HVAC, these are all pertaining to the energy systems in the home. And then they have another area dealing with security and safety, some areas dealing with health because you don't want to neglect anything, and something dealing with multimedia. So the IoT is really does not discriminate. It allows you, if you are only focusing on energy for the home, then you pick up the first group. and then concentrate, and that IoT will be able to help you with that. And you could connect with the developers that can work with you on that, or have some third party that help to install the sensors that is needed to do it. And these are also could be exemplified. So we have a prototype talking about the appliances. It has some video surveillance, cameras being connected, metering being connected, and also HVAC. And these were demonstrated to utility companies saying, hey, this is reality, IoT is reality, and here is a prototype of that. So that allow the utility company to study how they can do more research, how they can do modeling for pricing, and how they can do feasibility, how they go with certain regions and look at the challenges that they are facing in terms of providing connectivities. So, or if you have electric car that needed, consumption of power. So as you can see, all of these things are being exemplified. They all exist in some way or the other in different parts of the world. And now coming to the bigger sketch, which is, you don't want to really do a point solution. I have been spending a lot of time talking from a user perspective, but you need to look at it also from a utility company's perspective and the path all the way to the consumer. So it is really an IoT give opportunity for end-to-end solutions, all the way from the grid down to the appliances. This is the way that actually, over time, will represent a win-win situations, because the utility will have much more efficiency and reduction of cost, operational costs, and so on, and increase in productivities and increase of equipment performance as they install different gadgets and different ways of monitoring failures and detection and isolation and prevention. And of course, extending these capabilities to minimize failure and downtime for end consumer, but also enable them to use some pricing model to be able to leverage the benefit of being a good citizen and using the technology in the right way, being conscious of also the need of other people in terms of demand for electricity. You extend the home to the neighborhood, to the environment, and as you can see here, SCADA system still exists, collective concentrations of so many points, and along with the metering systems, helping the utility company to be able to manage the operations. It's really a question of applying different technology for and capabilities and techniques to move. So if we try to dissect that from area to area, as I said, I only give a high level view of standards. Now you can see standard associated all the way from the grid to the appliances with a wide area technology in neighborhood area network and down to the home area network. And what would be required for each, the connectivities, the protocol that will be required. It's nothing really, just showing the flow, and many companies just focus on one area, one increase. I want to minimize my operational cost, period. So that's the area, let's say, they will focus on. Maybe they will move to the next level in terms of lowering the cost of operations in the field, etc. And these things also were exemplified with some different tools, with this smart thermostat that exists today that help it to be Nest, for example, to be programmed and to be extended, along with other gateway type of capabilities and smart metering, and smart appliances, smart plugs, and connecting that to the cloud. So all of these things exist today in different ways. So what companies are doing is showing to the utility company, this is some of the things that you could leverage technology to do. Companies that spend R&D to investigate certain areas, maybe more on the technology variations or performance, and maybe some on the operational side, maybe some on the overall networking side, etc. So here's something in terms of monitoring and maintenance. of transformer, let's say, on poles. As you know, you could always dispatch trucks to figure out where the issues are. That was not far away. 2 years ago, we had the same things. And whenever there's a power failure, you see all these trucks, utility truck companies, coming to the poles and trying to see which pole in which area that has failed, which transformer that has failed. And they can ask the neighbor and trying to figure out what's happening. Well, that's gradually disappearing. Because now there are signals to be sent from the area where you could sense the transformer side, where there's fire or things like that. There are things that could be managed remotely. There are things that can happen today that you can even advance and use. I thought I have one. I think next one. You can use drone to go and actually inspect what's in a particular pole. If there is a file, take a visual, video streaming, and send it back. So these are all assistant mechanisms to do that. You could also move and advance in things like virtual reality, augmented reality for maintenance. You can inspect any particular transformer because you already have the 3D pictures of it, and you can, as you run your regular maintenance routines, you could look at the picture, what you have reference versus what you got, and do some analytic on the spot without having to send all these trucks and be able to analyze and jump on the pole and figure out what is going on. So this is all going back to the simple picture I put in the past in the beginning, is remote management and diagnostics is the key. It's really a matter of applying what technology to be used. Now the same thing for street lights. In the US, for example, it said that street light accounts for 30% of all the energy used to generate electricity for outdoor lighting. And estimated that if we save energy, that saving could power 5.8 million homes, US homes per year. That just simply from street light by switching from conventional lighting system to an LED. Lower the operation cost, longer life, environmental friendly, and so on. That's just one simple fact where some saving could be done from a utility company perspective. Switch all the lighting to be LED for the street. And the concept of a building is nothing more than an extension of the same philosophy that we have. You have a sprinkler system, you have access control systems, you have an HVAC system, etc. The same principle, except in bigger companies you have, or bigger campuses, you have maybe security at different locations. Maybe you have a network of security center that managing multiple buildings and so on. Concept is still the same. As you can see here, you really go through the same elements of managing these things at the modular level and be able to integrate it from one building to the next. So that in the future, you don't have to have, I don't know, if you have 10 buildings, you have to have 10 people managing each building individually. You could manage these virtually with one control center. So that's the changes that IoT can bring to the table. And it is accurate, you know exactly where the failure is, and you can also identify the root cause of the failure so that you could have the proactive approach of how to remedy that failure. So that's the IoT second principle in terms of advantage. It identifies the root cause of the problem, not the symptoms, the root cause. There's fire. There's fire in the transformer or fire somewhere. We don't know what's going on. With IoT, by placing sensors that are relevant for your needs and getting the information, we'll be able to identify the root cause. As we have today, I mean, in a simple fashion in the home for alarm systems, you have it by zone. It's a zone level. And it can tell you if there is somebody opening the front door or somebody opening the windows or so on. It will give you LED identifying the location where that violation of the access is happening. You can move from zone to individual units if you want to, if the cost is not an issue. So the same principle for bigger buildings, you can trace down the cause of a problem and be able to, the challenge is how we will solve it as quickly as possible and as efficient as possible. So if you know your systems and you know the functionalities and you already know the cause, you should have in plan emergency procedures to to recover from the situation that you're in. And other things are helping a lot, video surveillance and analytics. Now they can go analytic to nth degree. You can facial recognitions, license plate recognitions, etc. All beyond just simple access with a card. There are much more advanced and sophisticated systems. So this is moving to a new level in terms of management and control. And you could say, we have a real example of a smart building that's really looking at all these aspects about purity of the air, for example, the temperature, the HVAC systems, the lighting systems, all of that. And we have examples actually. It's not in the US, it is in Canada, and it is a hospital. It's one of the largest hospitals, and it was inaugurated in 2015. It's 1.75 million facilities. It has 656 beds, 3,000 staff, and so on. So it is a large size. You cannot just simply neglect it. But they study it very well, and they build it in such a way that everything is clean and proper. And there are many slides, but I only picked up one slide because it is huge. You have autonomous vehicles actually to transport food and things from one pavilion to the other. Elevators are giants that can take you from one floor to the next. Everything is interconnected and everything is managed. So that's really a true example of a smart connectivity in a building. In that case, it happened to be in a hospital. Yes?
Is there any legislation to regulate this technology?
Yes, there is.
Regulation or legislation?
Revelation.
Regulations to carry out
Regulation
to carry out the technology.
Yes.
In the United States, I don't know if you are or Mexico. If you have examples of that.
This whole arena of building automation, it's a movement, but it is not highly regulated yet. In a sense, there is no policy and procedures and regulation for developers to build according to certain specifications. I would say the guidelines is the same, whether it is in Canada or US. The implementation takes longer from regulatory to examine it and to analyze it in nth degree. And I think that's what's happening. But essentially, that company, it's not a company, it's a non-profit organization called CABA, Continental Building Supervisory, non-profit organization issuing guideline for all developers. It operates in Canada and US. So it's dealing with a lot of Schneider's and Johnson Control and General Electric, and all of these companies are following. They are endorsing the concept, definitely. The question is the degree, and if you go back to retroactively and try to fix a legacy building, that could be highly costly. This happened to be building fresh from the beginning, so any green development, meaning from start, from scratch, will be much easier than trying to fix a legacy building and so on and trying to add all these new gadgets and systems into it. Does this help?
Yeah, thank you.
I'm also part of what's called HIMSS, Health Information Practitioner. They bring in, it's about 60,000 in attendance every year. They alternate between Orlando and Las Vegas, but they bring all the advancement in technology for the operations, all the way in the emergency operations, but also the environment, studying the environment. And I'm part of the conference organizer for bringing that notion. So essentially, we are bringing Johnson Control and General Electric into the show to demonstrate some of the environmental implementation, so that it could be way of educating hospitals and leaders in the hospital. Because in general, health is the most neglected area, and if you talk to physician or surgeon and so on, this is the last thing they want to worry about. They just worry about the patients and surgery and things like that. So it's taking a longer time. And the same for manufacturing and car assembly and things like that. The robotics certainly is playing and will continue to play a major role in terms of production, productivity, efficiency, etc., and advancement and precision. So all of these things are coming along. Now, so hopefully these give you a bit of examples in terms of smart connected home, smart building and environment and energy management. Now I'll just touch, we have how much we have? Okay, we have maybe 10 minutes to go through the trends. How you look into the futures in terms of what to consider. So whatever I showed before, showing examples of implementations from sensing to communications to services across one area. I call it building energy and smart home and energy efficiency, to covering multiple things like video surveillance, disaster management, track, monitor, for example, or your fleet, for example, the company fleets and so on, how we are managing that. So IoT can go anywhere. Depends really what you want to characterize. If it is the subject matter, which is energy, for example, then it will focus on the energy. And if it is for the home or whether it is for building and so on, then you have. But my point is that it is common approach, regardless of the vertical market. Implementation will be different, because as I highlighted, there are different guidelines, different communication protocol, different criteria that you need to face. But going back to the question of SCADA for so, it's all moving from one generation to the other. It is evolving, but it is still functioning in the same way as intended, but with a lot more enhanced features and capabilities. To scale, then you need also to look into a platform to accommodate all these types of technology that we talked about. You need a sensing layer with all the protocols, multi-node end, machine-to-machine, control gateway, etc., to the next layer in terms of virtualizations. And as you can see here, you need to look at interwork with multiple communications protocol as you move to the next layer up of getting rollout in terms of application and services, and then the higher layer in terms of rolling out of services. So many companies, because IoT does not have a comprehensive standards today, you may be surprised, but relying on everybody else. There are groups, depending on the area, for energy management, there's a group for health, there's a group for home automations, consortium of companies that get together, including the vendors, and specify, okay, now we have to enable these capabilities for the home. So they get together and build up the specifications. If they all agreed upon, then they will all follow and implement that. And that's the way it goes, let's say, with the home automation. Similarly with the health and energy. Question? So the two key things I mentioned about virtualization, one is called network functional virtualization, and essentially replacing all the traditional systems by software that's running over what's called commodity server. So you will have a non-brand server that can be a router, could be a switcher, could be a firewall, could be a VPN gateway, and that saves tremendous amount of manpower for service providers. Instead of studying and learning and getting educated year by year through different, typically a service provider would have a minimum 2 vendors. Imagine if they have multiple and they have all these different brands of equipment that people have to learn how to configure, install, etc. All that saving that will generate just from area of training and operations and maintenance is huge. And then for software-defined network, the idea is moving everything in terms of software, getting it to be standardized in terms of silicon rather than custom ASIC, and looking at the centralized control plane and move instead of proprietary type of protocol, we'll have application protocol type of interface. Instead of moving from hard embedded policy, you will have more of a policy-based type of management for applications, and then that will help in terms of vendor releases and rapid innovation cycles. So these are the two NF, network functional virtualization and software-defined network, help a lot to save efforts and time for service providers. So if you look around you, these are companies you're familiar with in terms of focusing on specific areas. As I mentioned earlier, these companies also trying to reach the next layer, and by collaborating with other firms to deliver more of a common solution, or either work or partner. The end essence of the day is that IoT attracted everyone, and IoT gave the glimpse and hope that everyone can make money. So therefore, it's left up to each company to figure out how they can get extra money, either by acquisitions or branching to a new business or increasing the R&D funding, etc., whether they want to do it. There is not a single company can do IoT solution alone by itself. It's all based on collaboration or acquisition or a partnership. So that's a classical way that we have, but moving forward, it's really more about it. And as you can see here, everybody heard about IoT. Really, as you can see, tremendous attraction in terms of vendors, because they all want to be part of the ecosystem, so that when you are a part of the system, other people can use your piece of the solutions. And if you're looking at the ecosystem, not just for utility, I maybe emphasized a lot about energy technology and utility transformation, but also you have the electric cars that are coming in, or autonomous vehicles, building innovations. All of these things were becoming a big integral cycle that all connected or waved in or threaded with IoT. And then each area can give you a set of capabilities and differentiation and features that you could say, hey, I want to focus on my R&D in terms of energy technology and renewable energy, or in grid type of energy storage, or in the microgrid, or in the distribution. So IoT conferences, we have a lot of conferences that actually address all of these areas individually, and we have call for paper and then call for companies to collaborate and discuss and share their vision, share their best of practice, as well as share their challenges. We had one actually in April that I did happen to work hard to be the chair for it. It's called the Green Technology of a Smart City. So the notion that as we're moving towards IoT plus a number of other technologies helping to shape communities, helping to shape cities, and helping to shape countries to be what's called smart city, smart country, smart state, or smart community. So we're in that directions. And one of the ways to reap from all this information that we're collecting, it's what's called, this is from CAPA, by the way, about intelligent building, the way they view big data. It's defined as the next generation in business and operational intelligence derived from analysis of data integrated across multiple streams of sources for the purpose of overall system understanding, performance optimization. So they are starting with injecting the common vision and also looking at the stages from visualization, fault detection, predictive maintenance, and continuous improvement into optimizations. And that's where the analysis of information could be used in multiple stages. in the installation, in the configuration, in the provisioning, as well as in the maintenance and support, as well as the thing in training new people and so on. They may go through these captive type of approaches. Well, these things are also one of the branches that CABA, that organization, is moving towards in terms of use cases and using the big data for it. So they see a big challenge in terms of managing facilities, the energy, and the business operations. So here comes 2020 coming around the corner. What we see happening. So from we see a lot of connection, people being connected. We see a huge market of $4 trillion. The mobile app, the apps that we see today, maybe about 8 or 9 million. That will jump to about 25 million by 2020. And all the embedded systems kind of could be one of these systems. So we'll see about 25 billions of these worldwide. And the data that's being collected from sensors and systems going somewhere around 50 trillion gigabyte data. So that's a huge picture. That's why everybody's trying to use that as a landmark of the ages we're in terms of how technology is going to impact companies, impact municipality, impact the citizen, and all of us collectively. Last word I want to talk about is wireless technology. So we're all witnessing I think here, I can't remember now, we have LTE, we have fourth generation, and as you can see, focusing a lot on IP services and data, versus 3G was focusing a lot on voice, and can give you about 100 megabit per second. But why 5G? What difference 5G is going to offer us? Here's a quick example with comparing 4G against 5G. So overall, you will see now we're all taking pictures and video streaming and things like that. That was not possible with 3G or even your machine, your mobile device ran out of storage very quickly the minute you take a few minutes of video. If you take maybe a few thousands of pictures, also the storage will be gone. Now with the new devices, like iPhone 10 or whatever, you have about 250 gig. We still have that. With 5G, you have much more capacity, unlimited, and they're increasing that for mobile devices in terms of video streaming, IoT sensors network, augmented reality. So you can see now people coming fancy way of saying instead of going, if it's so crowded and instead of going to the stadium, you could use augmented reality and watch the game, let's say with your augmented reality the glasses or whatever, augmented reality device. The other thing you would see, the data speed is going higher. So we said the highest download speed is 1 gig. For 5G, it will be 5 gig. And the latency is going, when I did the systems, actually, the Teleglobe was about 200 milliseconds. And now with 4G, it's about 10 to 40 milliseconds. And in 5G, the theoretical promise is about 1 milliseconds. So that's still hard to achieve, but that's really what the spec will tell you in terms of 5G. So as you can see, focusing a lot in terms of Internet of Things, Internet of Humans, connecting machine to it, and adding on top of the other layer in terms of voice and data. But that's really beginning empowering. So 5G, when it is in the spec, different than other generations. They are specifying 5G to deliver services, not just the technology and not just the speed. But you are so much interested in Internet of Things, you are so much interested in the wireless sensors network, smart home, smart grid, intelligent transport system, virtual reality, medical sensor. So that's why I wanted to make sure that you are aware 5G is designed for your applications as well as other applications. From beginning, from the spec side of it, compared to 3G has nothing to do, or 4G has nothing to do with services. And that's why it's causing a lot of service provider a headache in terms of defining what business model should we use. How are we going to charge all these services? Nobody knows yet. I mean, there's nothing concrete being shared or being debated about services. How is it going to be? Suffice it to say, we don't know yet how services will be rolled out, in what degree, in what area, and so on. It's really left in the hands of service provider and whoever come to replace or to work with service provider to figure these things out. But as you can see, it's managing the whole complexity of the environment that we live in. And as you can see, service provider watching carefully the change in user, because now everybody wants. I don't want to figure when we're in the hotel and Wi-Fi drops, we get so angry because we're not connected anymore. It's becoming part of our nature. You don't want to see being disconnected. And service provider knows that, and knowing that Wi-Fi is a non-guaranteed service, but they want to ensure that 5G with the speed and all the promises that they have should be guaranteed service, but also they are going to offer 5G as a non-subscribed, non-guaranteed service, similar to Wi-Fi. So it's essentially going to compete with Wi-Fi in a green type of environment. They are watching in terms of new type of applications, as you can see here, and what's the profitability in terms of for operators, in terms of simplified management and utilization of hardware. ITU is also participating in the exercise, as you can see here. Smart city coming in terms of massive sensors that is bringing in a lot of data for analytics and the usage of, at the other end, augmented reality for in terms of enhancing mobile broadband. So 5G is going to help with mobile devices, number one, as promised, but it's also going to help all these vertical markets to leverage the technology. If you haven't seen, this is a roadmap for 5G and associated releases. So today I think, our release 15 should be voted in September, frankly, and release 16 will be voted in next year in September. There's a bit of offline here in terms of alignment, but that's today where we are in terms of finishing release 15 and going towards release 16. It is in parallel also with the LTE, so they are not going to abandon the LTE activities from advanced E and phase A, phase B, phase C, or from the IEEE from a spectrum perspective. Just this is a quick summary of 5G capability and features, and trying to relate these features to what it means to us. So we still cannot serve public safety with the response that is needed, especially with LTE. That will come somewhere around 2021. Otherwise, there are a lot of people developing private proprietary protocol, but a lot of focus is coming towards the autonomous vehicle-to-vehicle communications, and by lowering the latency and all these device connectivities and massive IoT and optimization. Using a lot of technology, so there's a lot of pilot tests in different cities. We have a few in US, and the biggest one that have impact in terms of disruption, where it's mentioned high, the millimeter wave, as well as network slicing. But all of these things will be available and interchangeable, so you don't have to physically, when you roll out 5G application and services, you will have all of these things lined up, and there will be whatever application you'll be running, depending what's needed, will be configured according to what's being installed. Network slicing is nothing more If you are familiar with the concept of VPN, virtual private network, it's really taking a slice of your network and dedicated for a specific purpose or specific services, isolated with security, so it becomes a guaranteed service, but in the context of, let's say, a public network, and rather to give you a high level of securities and guarantee. And here we're showing different slices used for different purposes. Some could be used for automated driving applications, some could be smartphone, some could be for drone, some could be for industrial robot, some could be for virtual reality. So that's coming in a big way, and that will be an economical cost benefit. And I would term it also, because I asked the questions, how about this will go definitely in urban area, but how about rural areas that do not have the luxury of having 5G and so on? And with network slicing and small cell, you probably can pick and choose a couple of areas and then penetrate that at a lower cost, roll out as a lower cost. That's more of showing the stack of how things today are done with 4G, piping in application in one area versus having protecting different, the traffic for each application separately. Adding to it the next layer up in terms of virtualization or network slicing rather, and adding a third layer. So you have layers of IoT. Some could be dealing with the mobile phones, some could be dealing with the autonomous vehicle, etc. Spectrum is a key area, just for your information. So our US is running typically under 3.5 gigahertz, but Verizon Sprint is running at a higher rate. The harmonization effort is going across Europe, Asia, to deploy 5G for 3.5 gigahertz. So that's something, as many carriers working on commercial trials, they are working in terms of that level of harmonization for interworking. So talking about people usage of how they could benefit from 5G in terms of wearable, virtual reality, high resolution, multi-view, video in real time, different applications. Or in terms of aerial vehicles, all types of usage for drone, for emergency. We have emergency drone for ambulance, for fire, for, as we saw examples for pole transformer caught on fire that we send the drone to stream video information. And overall, you can see have impact into various cities and different functions. And different consortiums are working towards activities and standards. But all of these things, so one would ask, what is a smart city? So smart city is still subjective. So I would say anything that have more than 2 or 3 vertical markets that is being smart would constitute to becoming the beginning of a smart city. Example, transportation or public safety or smart well-being or smart energy, smart building, and so on. So if Mexico City pick up several of these things, it will qualify Mexico City to be a smart city and so on. Any city here could be also qualified to be smart city if you do the initiative with the more in terms of energy and smart grid and building, connecting building and homes. These 3 constitute, you could claim and produce evidence that you have actually the notion of a smart city. Typically, what can we formalize what a smart city? So I put the definition here. First, it really drives economic growth. B, it improves quality of life. And C, it's really sustainability. So whatever you do is not one-shot deal, but it's rather sustainable. And it can go across all these types of vertical markets. Video is driving and video streaming is driving it. As you can see, mobile, 60% of traffic is mobile. traffic for infrastructure coming from different sources, from car, connected city, consumers, health, home, energy, as you can see in the color code. This is all helping in city planning as you are doing research and development planning for the future consumptions of energy and so on. Help you to identify that in conjunction with other type of traffic that's growing. So we're also trying to move into open source, especially open source with artificial intelligence in a number of areas, telecom infrastructure, cybersecurity, and digital services for a number of areas. And this is what could be a cluster of smart islands of activities of vertical markets. But the essence of the whole, this is the final picture, is really to show that technology as you integrate, it gives you evolutions towards better and scalable and efficient and reliable and higher capacity type of infrastructure and network to be able to serve multitude of areas from solar energy applications to entertainment to transportation to medical care, and gradually beginning in 2020 it will really transform also our social value as a social value platform, but transform our view in terms of getting hopefully receiving a better quality of life and having a more of an ecosystem for the industry and a safer cities with the public services. So the conclusion is, we have definite growth in terms of IoT with 25. Now it's projected 50 billion by 2020. For IoT, every life matters and every asset matters. Just remember that word. Every life meaning that all of us, with all these sensors that are coming, wearables, for vital signs and so on, to serve us for diagnosis and analysis, that's important. But every asset around us, with all the pictures and objects that we talked about, also matter. IoT identify the root cause, and with the collaboration of other technologies, really to be able to determine the solution. Collaborative technologies such as 5G and virtualization are opportunities to leverage the IoT, lower latency, higher performance, virtualizations, getting much bigger and scalable type of systems that improve quality of life. This is the book that I was mentioning about that has a lot of areas covering actually these similar things that we just talked about, but with hundreds and I would say tens to hundreds of examples that could come about in the 2025 to 2035 and beyond. So with that, thank you very much for your attention and participation. I'm open if there are any questions. Yes.
Thank you very much for the presentation. I have a question related with the demand response. We have developed smart meters, smart plugs, smart appliances, and I would like all of them with the aim of making people aware of the energy consumption we have. Sorry. And I would like to know if you have some experiences of data, real data, of the demand response concept with the electrical utilities.
Not the hands-on experiences, but I did read about some examples, and I think some in Australia, those who are really working diligently in these areas. I would say in Australia they are doing a lot of work in that area. I could maybe refer you to some references that could help with the information. Unless you have really specific question behind.
Oh, that's all right. I mean, reference would be good. And yeah, another question that I do have is related to the merging of the IoT with many fields. It is health and fitness, transportation, etc. And I just recently was in the city of Manchester in the UK, and they're trying to make the city smart, connecting transportation, hospitals, etc. And there are a lot of appliances, all of them wireless. Also, it's a big issue of security that the system could be hacked. Can you tell us something about it?
Yeah, just a refresh from the previous question. It all, in terms of demand and response, it all also goes with the proactive planning. So what emerged in the last couple of years that every municipality, which has crown corporation, not crown corporation, they have a utility company that's part of the government, that part of the municipalities. And energy, for example, Austin Energy, is connected with a lot of initiatives dealing with solar energy and performance and utilization. Has also managing the transportation autonomous vehicle, believe it or not, because they feel electric car coming in and will have a certain percentage of consumption. But the point I was trying to stress, municipality have two offices. One is called the Office of Innovation, and the other one, Office of Chief Information Officer, in a way. Something like fancy, better fancier than Chief Information Officer. But both of them are examining all the things that I'm just mentioning, supported by other consortium. So for example, in Austin, we have something called Austin City Up. So Austin City Up has about